Aloha, this is 1.11 notes. We're going to be solving equations and inequalities graphically. And as you can see on the left-hand column, we're also going to be solving them algebraically and comparing them graphically. So let's start off with that first box, 3x minus 4 equals 1. And we're going to solve for x. We're going to eliminate the 4 to the other side to isolate the x. And we're going to eliminate the 3 to continue to isolate the x. We're going to get x equals 5 over 3, which is approximately 1.6x. And with that same equation, we're going to graph it. So remember that when we're trying to graph any linear equation, we need to make it equal to 0. So I'm going to push the 1 to the other side. We'll get 3x minus 5. And with that, we can rewrite it as y equals 3x minus 5. The 0 turns into the y. And 3x minus 5 says that we start at negative 5, and we go up 3 over 1, up 3 over 1, up 3 over 1, and we keep going. We really only need 2 points, but I'm just going to go through the whole thing. Okay, let's connect our dots. And we're going to look at the x-axis and approximately where that line crosses the x-axis. So I know that it's more than 1.5, but less than positive 2. And we also know that we got 1.66. And so our answer we're going to assume is correct because this is approximately 1.66. So again, when we're solving graphically, you make it equal to 0, substitute y in for 0, and graph the problem. Okay, for solving a quadratic equation, I'm going to take these equations first and plug them into a graphic calculator just so that we can see what it looks like. So we have x squared minus 4x plus 2, x squared minus 4x plus 4, x squared minus 4x plus 6. Okay, so pull up your calculator. We're going to go y equals, we're going to say x squared minus 4x plus 2. And I'm going to graph. And as you can see, it hits, our calculator tells us that it crosses right there at 3.4. And down here, on the bottom of your calculator, it'll actually show you what this point is. It's down here in the blue and black. On this side, I'm going to tap this, and it's about 0.58, so about 0.6. So we have 0.6 and 3.4. So x equals 0.6, x equals 3.4. Okay, let's do the next one. I'm going to delete that and put 4, graph. And as you can see, there's only one x-intercept, and it's right at 2. So we're going to say x equals 2. And then C, let's go back to the calculator and put delete 6. We're going to graph it. And, sorry, I'm going to make this smaller. There we go. As you can see, none of the parabola touches this x-axis. So it doesn't ever cross through the x-axis. So we really don't have any numbers. And so I'm going to say this could be what we call imaginary. And when we work it out algebraically, you'll be able to understand why I said imaginary. But it never crosses through. And one thing I should have made clear is that when we're solving algebraically, we're going to get this x answer. The answer graphically is wherever it crosses the x-axis. So that's how we compare algebraically and graphic answers, is that the answer that you got for x when solving for x should be where it crosses on the x-axis. So let's go to this first one. And I'm actually going to solve it by using quadratic formula. And quadratic formula we know is x equals negative b plus or minus b squared minus 4ac all over 2a. And I'm going to take my 1, negative 4, and 2, and plug that in. So negative 4 plus or minus, oops, go away, sorry. 4 squared is 16 minus 4 times 1 times 2 all over 2a. And this is going to equal 4 plus or minus the square root of 8 over 2. We can simplify this to 4 plus 2 root 2, because the square root of 8 condenses down to 2 root 2, or simplifies. And then as we can see, we have numbers here that we can cancel out. So 2 and 2 cancel out, and 4 and 2 cancel out to 2. So my answer would be 2 plus or minus root 2. And I can promise you that if you work that on the calculator, 2 plus root 2 and 2 plus root 2 is going to be equal to 3.4. And 2 minus root 2 is going to be about 0.6. And that was the same answers that we got where it crossed. Okay, our next one, B. B says x squared minus 4x plus 4. And I'm just going to actually solve this through factoring, because we know that what times what is negative 4, sorry, is positive 4, but when added together is negative 4. And that's going to be x minus 2 and x minus 2. And that's going to be the same thing as x equals to positive 2 and x equals to positive 2. If we ever have the same with the two same answers, we're really only going to bring it down to one answer, which is just 1, x equals 2. And that's going to be the same answer that we got here. Okay, the last one, C. I'm going to, again, use quadratic formula, because as I'm looking at 6, I know that the factors of 6 do not equal to negative 4 when adding it up. And so let's plug it in. We're going to say x equals negative 4 plus or minus the square root of 16 minus 416 all over 2. If I simplify that, I'm going to get 4 plus or minus 16 minus 24 is negative 8 over 2. I know that negative 8, because it's a negative under the square root, it becomes an imaginary number. So it becomes 2 root 2 I. I'm going to cancel out 2's and the 4's, and this answer is going to be 2 plus or minus root 2 I. And this is why we call that an imaginary number. Again, looking at this and knowing that it did not cross the x-axis. So there really is no answer. And that's where how imaginary numbers come into play. Okay, next example. When we're solving algebraically, again, we would get all the x's to one side of the equation and numbers to the other side of the equation. And I'm just going to move x's to the left. I'm going to move numbers to the right. And this will become negative 25. This becomes negative 11x divided by negative 11, negative 11. And I'm going to get x equals 25 over 11, which is about 2.7. Okay, let's graph it in the calculator. Okay, so in the calculator, the way that you would take this type of equation is you would create two equations. We're going to split this equation down the middle. 5 minus 3x equals 8x minus 20. Okay, and again, we're going to split it down the center. And we're going to create two equations. The first equation is going to be y equals 5 minus 3x. And the second equation is y equals 8x minus 20. So again, we took the equation, we split it in half, and I'm going to take these two equations and plug them into my calculator. So again, y equals 5 minus 3x, and y equals 8x minus 20. That's clear. And let's put them all in at the same time. Minus 3x, and this one is 8x. Is it minus 20? Hold on. Yeah, minus 3 and minus 20. Okay, so we're going to graph. And this is what the graph looks like. And I'm actually going to zoom in and look at where it crosses. And as you can tell, hold on, let's bring it down. It's going to be somewhere here, about 2.5. And as you can see, no, sorry, it's less than 2.5. So it's going to be about the middle of 2 and 2.5. And what did we say? We said it's 2.7. I'm probably wrong. Okay, let's use the calculator. Let's figure out what that is. So this is probably going to be about 2.25. Let's go back to our calculator. So to get out of the graphing mode, you go second, quit. And that takes you back. So that should take us out of graphing. Okay, there we go. Second, quit. I'm going to go 25 divided by 11. Yes, I was wrong. It's 2.27. Let's correct that. And then again, where did it cross? It crossed about 2.25. So we are very, very close. And again, that's how you solve it graphically for an equation that has an x on both sides of the equation. Okay, next page. Here we go. So on this one, I actually wrote it wrong a little bit. And so you're missing part of the equation. It says, graphing on the calculator with an interval. Solve the equation in the interval 1, 6 and negative 5, 5. And this is what the equation should look like. So before we actually plug it into the equation, to the calculator, remember that we can only have, or everything has to be equal to 0. So I'm going to minus this square root to the other side. And what does it equal? X to the third minus 6x squared. Make sure you put that x in, I forgot to. Plus 9x minus the square root of x equals to 0. Okay, so this is the equation that we're going to punch into our calculator. And then this is going to be the interval that we plug into the window. So we have 1, 6 and negative 5, 5. Okay, so this is x cubed minus 6x squared plus 9x minus square root of x. Okay, let's go back to your calculator and let's go back to y equals. I'm going to clear both of these lines and I'm going to punch that in. So we're going to say x. Whenever you're pressing cube, you're actually going to press this arrow. That's the arrow button under clear. That looks like a, just like a arrow up. And then you're going to press 3, and that's going to give us x to the third power. Whenever you do a exponent that way, you actually have to press on this arrow to the left, sorry, arrow to the right. So above clear, click on the arrow to the right, and it's going to bring that cursor down so that we can put in the next one. And I think the next was negative 6x squared. Negative 6x squared. And was it plus 9? Yep. Plus 9x minus the square root. The square root is going to be here above x squared. So we're going to say second x squared. It's going to give us this radical sign, and we can plug our x in there. So this is what your equation should look like. X cubed minus 6x squared plus 9x minus square root of x. And let's graph. Actually, sorry, no, we're not graphing. Before we graph, let's press on window, the second button. And it wants us to adjust our window to 1 and 6 and negative 5, 5. So we're first going to be working with the x's. We're going to clear this x, and we want it to be 1. That's the minimum. Our maximum we're going to clear, and we're going to make this a window of 6. Our minimum we're going to clear for the y and make it negative 5. And y we're going to clear for the max, and we're going to make that positive 5. Now, when you're putting in negative 5, make sure that you're using the negative sign on the very bottom of the calculator next to enter. So it looks like a negative sign in parentheses. Do not use the minus sign above enter. Again, you must use the negative sign next to enter. And once it looks like this, we're going to press on graph. And that condenses our window to a very small section. And your calculator might need time to think. I was like, it doesn't even have, oh, it's giving me syntax error. Hold on, let's look again. Let's change that to minus. Let's see if that works. Here we go. Okay, we're going to go back to the window. I want the window to be condensed. So I'm going to go 1, clear 6, clear negative 5, clear 5, graph. And this is what you should see. And let's zoom in. This is equal to 2.2, or actually approximately 2.1. And let's go to the other side. And this side, it's about 3.7. Sorry, I don't know where it was going. Okay, 3.7. So what is this equal to? This is equal to x equals 2.1, and x is equal to 3.7. Again, on the calculator, my answer is right here. It says 0, 3.7. And I'm going to click on this other 0, and it's 2.1. your zeros are the same thing as your x-intercepts. Okay, and that's how you find your answer with an interval. Okay, let's go ahead and tackle the next equation, which is 3x minus 4 is greater or equal to 1. And solving algebraically, we are going to solve for x, so we're going to add 4 to each side. I'm going to get 3x is greater or equal to 5, and divide by 3, divide by 3, x is greater or equal to 5 over 3. Okay, looking at it graphing, we want to make it equal to 0. We're going to get 3x minus 5 is greater than or equal to 0. And when we rewrite it as y is equal to, no, sorry, is less than or equal to 3x minus 5. And the reason why it's less than is because if I was to substitute y into the 0, the tail is pointing at the y. And so here, the tail must still be pointing at the y. Okay, let's graph. We have negative 5. We're going to go up 3 over 1, up 3 over 1. I'm wrong. Up 3 over 1. Up 3 over 1, up 3 over 1, up 3 over 1. Okay, let's graph it. And we're going to graph it as a solid line because of the equals to here. If it was not equals to, this would be a dashed line. But we're including any answers on that line. And so it's going to be less than or equal to with a solid line. Now this says y is less than or equal to 3x minus 5. And so we are looking at a graph with a positive slope. Because it's less than, we're actually going to color everything under that positive slope. So anything in this colored area is a possible answer. And the way that we know that we're right is because, shucks, oh my gosh. The way that we know that we're right is because x is greater than 5 over 3. And if we look at the number line, it has to be anything greater on this side. And so, again, we colored under because this is a positive slope. And if it's less than, we're going to go under the slope. If this happened to be greater than, then we would have colored on this side of the slope. But it's not. It was less than, so we went under. Okay. Our last two, graphing inequalities. We're actually going to graph this on the calculator. And this first one is very similar to what we did prior. We're going to take this inequality. We're going to split it in half. And we're going to rewrite the equation. We're going to set it equal to 0. So we have 3.7x squared plus 1.3x minus 1.9 is less than or equal to 0, which we know is also y. On the other side, we have 0, or y, is less than or equal to 2.0 minus 1.4x. And I'm going to plug these right into my calculator. I'm going to fix this. 0.9. Okay, 3x squared, 3.7x squared, 1.3x, 1.9. Let's use our calculator. Let's go there, let's clear. And we said 3.7x squared plus 1.3x minus 1.9. And then the second one, it was equal to 2.0 minus 1.4x. So 2 minus 1.4x. And we're going to graph. And this is going to show that one is a parabola and one is a straight line. And where do they cross each other? That is actually going to be our answers. And so as we can see, it crosses the x about 0.7 for that point. And on this side, it crosses it about negative 1.4. And that would be my answers. X is, let's say, greater or equal to negative 1 point, let me say 7? No, 1.4. And x is less than 0.7, 0.7. Okay, we're going to do the same thing with this equation. X cubed minus 5x squared plus 8 is greater than y. Let's graph it to our actual calculator, but instead of using the greater or equals to, we're just going to put it in as x cubed minus 5x squared plus 8. X cubed, I'm going to clear my calculator again. We're going to go x cubed minus 5x squared. Oops. Sorry, we gotta, so remember that when you are doing this, if you ever use the caret, you have to use the arrows to the side. Minus 5x squared plus 8. And let's just graph this and see what it says. Okay, the cube is weird. Oh, you know why? Because it's missing the x. That's why it looks weird. Okay, so where does it say it's going to cross? It's going to cross negative 1.17 and positive 1.5. So this would be x is negative 1.17 and x is equal to, did I say 1.5? Yep, 1.5. Okay, and that is graphing that is solving the equations graphically. Okay, our next section is going to be 1.12. And in 1.12, we're going to be looking at verbiage. And we're going to be creating equations. And then eventually we're going to take that verbiage, create equations, and then solve for variations. And so this is called modeling variations, and then we'll solve for variations. Now, this word directly means equal to, but straight across. When we're talking about varies or variation or proportions, we're going to be talking about this this variable k. Okay, and we're going to create an equation. When it tells us that there is a direct variation, it also means these things. Y varies directly as x, or y is directly proportional to x, or y is proportional to x. We are going to write an equation that looks like this. Y equals k, and then directly across from it, the next variable. So in example 1, it says t varies directly as x. So we know that the equation is going to look like this because it varies directly. But our equation says t varies means it's straight across, so equals. We have to put in our constant, which is our k, and it varies directly to x, so our next variable is going to be x. Okay, the next example, example 2 says directly proportionate to w. P is directly proportionate to w. So our first variable is p. Is means equal. Directly proportionate means that we're going to use a constant, and next to it is going to be our variable w. Again, directly proportionate here looks exactly like a direct variation. Next one. It says v is inversely proportional to z. Okay, so inversely means that we're using a fraction or division sign. Direct means that we're using multiplication. I should put that in there. We're multiplying. Inversely means that we are dividing or using some type of fraction line. Okay, so v is, let's rewrite that. V is, we know that is equals to equal sign, inversely proportionate. So this tells me that I'm going to be using a constant k divided by whatever variable they told me. Whenever we are using inverse, again, we create a fraction that looks like this, and we use division. So division or fraction line. Okay, example 4, it says w is proportional to the product of m and n. So this means that we are using more than one variable. So as you can see down here, when we're combining variations, when there's more than one variable, we call this the product. So w is proportional, so we're going to put my k, my constant k, to the product of m and n. And remember that when we have variables right next to each other, it means that we are multiplying them all out. Okay, the next one says, example 5, y is proportional to s and inversely proportional to t. So we have y is proportional, so we have my k, and it's proportional to s, so s is going to be right next to it. And inversely proportional means that there's a fraction, and it's inversely proportional to t, so t becomes the denominator. Okay, so that one had two things. It was proportional and inversely proportional. That's why we have the S up top, the T on bottom. Next one says P varies inversely as T. P varies inversely as T. So again, our constant K is on the top, but T was inverse, so it becomes our fraction. Example 7. Z is proportional to the square root of y. Okay, proportional again tells us it's directly across. So Z equals our constant K, but it's proportional to the square root of y. So right next to the K, or multiplied to the K, is the square root of y. Example 8. A is, so A equals, proportional to the square of x, so it's going to be our constant square of x, and inversely, so fraction, proportional to the cube of t, so t cube. Again, A is proportional, so we put our constant k, to the square of x, so we have x squared, and inversely means fraction, proportional to the cube of t, so t cubed. Example 9. V is, so V equals, proportional, so we're going to put our constant k, to the product of LWH. So this becomes L, W, and H. Okay, in our last example, it says R is proportional, so R equals K, to the product of the squares P and T. Okay, so to the product, we know that these are going to be multiplied, but also they are squares. So P squared, T squared. And inversely means fraction, proportional to the cube of B. Again, R equals proportional, I put my K, which is my constant, to the product of P and T, but it's a squares. So product PT, made them both squares, inversely proportional, made it a fraction, over B. And I'm actually going to fix this a little bit. The fraction should not be over by the R. It should only be the K, the KP, and the T. Okay, now that we know how to use the verbiage and write all of these equations, we're going to go to the next page and we're going to solve them all. So this one says y is directly proportional to x. So let's write our equation. Y is proportional to x. So if x is equal to 6 and if y is equal to 42, then what does our constant k equal to? So I'm just going to solve. Go backwards. This is the same thing as saying 42 equals 6k, because we're multiplying them together. If I want to solve for k, I'm going to... Go away, Siri. Oh my gosh. We're going to divide by 6, k equals 7. Okay, example 12. W is inversely, so W is my constant, but it's inversely to T, so it's going to be a fraction. If T is 8 and W is 3, what does K equal? Remember that when we have a fraction, we're just going to multiply it to both sides. So K is equal to 24. Okay, example 13. A varies inversely as R. So here's my A equals, inversely is my constant K, and that's it, inversely as R. So R goes on the bottom. Let's plug in our numbers. 7 equals K over 3. Again, in order to get rid of that fraction, I'm going to multiply it by the denominator. So K equals 21. Okay, P is directly proportional. So directly proportional to T. And P is 20. And T is 300. So let's rewrite it as 20 equals 300K. Divide by 300. Divide by 300. And K is going to be equal to 1 over 15. You can also use the calculator and get the decimal if it asks you to round to the nearest tenth or 100th. Okay, example 15. A is directly proportional to X and inversely proportional to T. If A is 42 and X is 7 and T is 3, let's solve. So I'm going to say, let's get rid of this 3 first. Or actually, you know what we could do? We could totally multiply this by the reciprocal. 3 over 7. 3 over 7. Oops, I wrote it wrong. This cancels out. And on this side, I can see 42 divided by 7 is 6. So k is equal to 18. Okay, last one. Here we go. W is inversely proportional to the square of r. W is 10, my constant k, and r squared is 36. Again, we want to get rid of that denominator by multiplying it to the numerator, and this will equal 360. Okay, if you have any questions or concerns with homework or with any of the notes, please don't hesitate to email. Send me the equation, or if you are lost at some point in the equation, just email and say, I got stuck at this point on this equation. Or if any of this verbiage is confusing to you, let me know. We can set up office hours and I can explain it more clearly and in person or virtually. Okay, again, have an awesome weekend. Enjoy 1.11 and 1.12. Okay, thanks. Bye.